Hello good people and welcome back to another video. This time we are going to be reviewing plate tectonics. Let's get started. Alright, first off on your quiz you're going to have a bit of matching, and these are the terms that you will be matching in the vocabulary section: Pangea, lithosphere, asthenosphere, continental drift hypothesis, convection current, plate tectonics, and seafloor spreading. Next we'll take a look at each of these individually. Pangea. Pangea is this supercontinent right here. It was the idea that all of Earth's landmass was hooked together in one giant landmass. So if you take a look at those closely, you can see some different continents on there. At one point, this theory says that they were all together, and this was about 225 million years ago. Lithosphere. This is the rigid upper layer of the mantle, and it has all of Earth's crust. So this is the lithosphere right here. So it is that harder layer, the land layer, and it sits on top of the asthenosphere. So as our continents move around a little bit, it is this lithosphere that we are talking about, which moves around. Of course, the asthenosphere, that's the one that we just mentioned. That is below the lithosphere. So the asthenosphere is right here. And this is a softer plastic-like layer that is more fluid and movable. And the lithosphere sits on top of the asthenosphere. Okay, continental drift hypothesis. This was Alfred Wegener's idea. We've talked a lot about this in class. And his idea said that at one point all of the continents fit together like a puzzle, and they were in this landmass called Pangea. And then over time these continents drifted apart. This theory was really not accepted at the time. It took a long time before his theory was accepted, and pretty much now most scientists are in agreement that this is what happened. Convection current. So our convection current, well, hold on, let me back up. There's a lot going on in this image, but we're going to be focused for this slide right down here on these convection currents. And here's the idea of the convection current, that the inner core is very, very hot. It heats up the outer core, which is also very hot, and then we're heating up the magma that's in the mantle, and as things are heating up, they're flowing up, and they flow up in this direction, and then eventually they cool, and as they cool they fall back down, and this process just kind of keeps being repeated. This is a circular sort of thing. It gets heated up, it rises up, and then it cools, and then it falls back down, and this just repeats. Well, this circular motion is what moves the plates, so moves our continents. So in this image, this plate right here, plate number 2, is going to be moving in this direction, and plate number 1 is moving in this direction. So that superheated magma comes up here and then moves in a circular motion, moving the continents. Alright, plate tectonics. This is the theory that Earth's crust is broken up into a number of plates that move. And we have outlines right here of the plates. You can see North America is sitting on this plate. Here's another plate right here. The continent of Africa sits on this plate. And it's the idea that these are all separate pieces and they very slowly move. Okay, seafloor spreading. I know we already saw this image, but we had this image when we were talking about convection currents. So seafloor spreading is this theory. It was proposed by Harry Hess in the 1960s, that hot material below the Earth's crust flows up, and as it's flowing up right here, there's this separation between plate number 2 and plate number 1. So it's kind of like there's a little space for that hot material to come out. And as it comes out, it is going to form new material, new ocean floor material that happens at this mid-ocean ridge So a little material right here, a little material right here. And this keeps on happening, and the material stacks up outside of that mid-ocean ridge as the plates move apart based on these convection currents down here. So all this kind of is happening together. The seafloor is spreading, and we're having new material being created in this area. Plate boundaries. Well, we have a lot of plates around the Earth, and they come together, and the places that those plates meet, we have something we call a divergent boundary, a convergent boundary, a transform boundary, and a subduction boundary, or at least subduction as a movement. We'll take a look at each of these. Again, we're looking at this same image we've seen a few different times. There's a lot going on here. Divergent plate boundary just means that the plates are moving apart. So here's plate number 1, here's plate number 2, and these plates are moving apart. As they move apart, there will be a space in between where this hot magma right here is flowing up, and that will create some new material. So the big idea with a divergent plate boundary is that they are moving apart. A convergent plate boundary. Well, it's the opposite. In a convergent plate boundary, they are coming together. So this plate right here is moving in this direction. This plate over here is moving in this direction, and they come together. And as they come together, lots of times in this collision, land gets bumped up. So that's how these mountains are being formed, because of the collision of these two plates. Again, the big idea, a convergent plate boundary, two plates are coming together. Transform boundary. I couldn't find a great image for this, so I drew my own. This is the boundary area right here. And in a transform boundary, there are two plates, and they are slipping past each other. So this plate, we could call this plate number 1, and this plate number 2. Plate number 1 is moving in this direction. Plate number 2 is moving in the opposite direction. They are slipping past each other. So in a transform boundary, we have two plates that slip past each other. Subduction. Just like a submarine goes down, a subduction boundary is where one plate goes under the other plate. So we have two plates meeting here. I'll show you what the plates are. This is plate number 1. And this right here is plate number 2. And they're meeting in this area. Now, when they meet, plate number 1 is the heavier oceanic plate. It's denser, and it is going to subduct or go under the lighter, less dense continental plate. And as it subducts, it's going down and down back into the mantle. So here's plate number 2. Here's plate number 1. They are coming together right here. And there's a specific thing that is happening. That is subduction. And the subduction is when that oceanic plate goes down. All right, another piece on the test that we have talked about is the evidence for continental drift. There's a lot of evidence for this. So, let's see. I'll kind of start actually with the last one first, and that is this idea of a puzzle. The continents, when you look at them, they fit so well together. You can see right here, South America and Africa, they just fit together like this perfect little puzzle. So that is one piece of evidence. Another piece of evidence is fossils, both animal fossils and plant fossils. Right here on these areas where the continents come together, we will find the exact same fossil. Even though these continents are now a few thousand miles apart, we're finding the exact same fossils there. And the same with plants. We can find evidence of a single plant fossil, Glossopteris, right here, on all of these continents. Even now, at this point, they are spread out all over the globe. But yet, this fossil, this plant fossil, is on all of them. Another is some climate features. We have areas of South America that are very warm, but they're showing evidence of glacial movement on them. So we have rocks that are carved, even though there's no glaciers in that area now. So we have an idea that at one point these were together and the Earth had very different climate features. And then, of course, the puzzle piece that I mentioned. All right, another review about the layers of the Earth over here. So on the very inside, we have the inner core. Then that is solid and incredibly hot. Then we have the outer core. Then we have the mantle. The mantle we just talked a lot about because that has to do with the whole theory of plate tectonics and how these are moving. And then the very thin crust that we live upon. Okay, that's it. A little review for Friday's quiz on plate tectonics. Hope that helped. You can watch it a few times. We'll see you soon. Have a great day.